When we're looking at quadratic patterns, their graph is a parabola. So any function that's got some x squared term in it, whether it's given to us directly or when we expand out, will give this beautiful parabola shape. But let's look at the most basic parabola there is. The most basic parabola, y equals x squared. We could think of this by making up a table. Let's make some values for x and some values for y and plot the coordinate pairs that they generate. So I'm just going to pick a few values for x. I'm going to start with 3, 2, 1, 0. And then I'll go into some negative values as well, just to see what happens on the other side of that y-axis. Negative 1, negative 2, negative 3. So when x is 3, 3 squared, 3 times 3 is 9. When x is 2, 2 squared is 4. When x is 1, 1 squared is 1 times 1 is 1. 0 squared will be 0. Negative 1 squared is negative 1 multiplied by negative 1, which is 1. And a lot of people, if they punch it in their calculator, they'll type negative 1 and push the squared button, and that might return negative 1. So just remember, squaring a negative number will give me a positive number. Negative 2 squared, negative 2 times negative 2, that'll all be positive 4. And negative 3 squared, negative 3 times negative 3 is 9. So this relationship, y equals x squared, generates these coordinates: 3, 9, 2, 4, 1, 1, 0, 0, negative 1, 1, negative 2, 4, and negative 3, 9. So now we can have a look over here, and we'll actually graph the relationship y equals x squared. So there's my y-axis and my x-axis. Remember, we'll label those x and y. Now I want to put a scale on here, so 1, 2, 3 for x, and I'll also have negative 1, negative 2, negative 3, and 1, 2, 3, etc. for y. So on. So let's plot these points. When x is 3, y is 9. So that's the point 3, 9 there. 2, 4. When x is 2, y is 4. When x is 1, y is 1. When x is 0, y is 0. When x is negative 1, y is 1. When x is negative 2, y is 4. When x is negative 3, y is 9. Okay. Now this, if I join these points up in between, I'm not going to join them with straight lines. It's a lovely curve, this parabola. It comes through, it's very symmetrical. So this side to the left of my y-axis is going to be mirrored on the right side to the right of my y-axis. And this is my graph, y equals x squared. And it'll continue upwards and onwards on both sides. Now there's some really lovely features of my standard parabola, the most basic quadratic, y equals x squared. If I go from the vertex, we call this bottom point, the nice rounded bottom, the vertex. If I move out 1 to the right, I go up 1. 1 squared is 1. If I move out 2 to the right, I go up 4. 2 squared. And if I move out 3 to the right, I'm going to go up 3 squared, which is 9. So my most basic parabola has this beautiful shape. It's a rounded bottom. It's got that lovely symmetry. Both sides are a mirror image of the other. Okay, and from the vertex I go out 1 and up 1, or I go out 2 and up 4, sorry, or out 3 and up 3 squared, which is 9. And the same happens on the other side. I go out 1 to the left and up 1 squared, negative 1 squared, which is 1. Out 2 and up negative 2 squared, which is 4. Out 3 and up negative 3 squared, which is 9. And that's the graph of our basic parabola, y equals x squared.